I wanted to go over a question 4 on the Canvas Momentum 1 quiz. Now, first of all, remember quizzes are the equivalent of mini CKs. The mini CKs don't count against you for your physics academic proficiency. They are used to help you boost your confidence and also for you to gauge your level of understanding before the actual game day CK. Now, question 4 was the one that said, explain a situation in which a golf cart could have more momentum than a large tour bus. So the situation is a large bus, yep, great bus, okay, wheels on the bus, and you have a golf cart. I'm just going to make it smaller. We'll say GC, golf cart. Momentum, remember, is inertia in motion. And this is the shortcut for that sentence, that statement, that relationship. Momentum, the symbol momentum P, because Galileo would refer to as point in space. Anyhow, P, momentum is inertia. Okay, a symbol to represent inertia. We know inertia is a measurement of mass. So mass, momentum is inertia in motion. So velocity, what we've been thinking about for motion. So the situation is asking, explain a situation where this golf cart could have greater momentum when compared to the bus's momentum being less. Let's first think about the momentum value of each. I do realize the question is just asking for a qualitative response, meaning words. This wasn't a calculate the momentum of the bus or the cart, but I think the numbers that I'll show you are going to help you understand why the response of saying the cart going faster, so having the cart momentum and the bus momentum, saying that, okay, momentum of the cart is very small. If it's going very fast, then perhaps it could have less momentum than the bus if it's going small. However, the mass of the bus is tremendous. And I want to show you how through the numbers, you can't really just say that the golf cart has to go a lot faster, because I'm going to show you how much faster. So let's use some numbers here. I just looked online for some typical masses. A mass for a loaded people, luggage, tour bus was about 13,500 kilograms, whereas the mass for a golf cart was said to be about 450 kilograms. The responses you've been giving of saying that the velocity has to be much, much greater is correct in thinking the velocity has to be bigger. But in order to take in the consideration of this large mass, let's just see the values. Let's make the bus move at a pretty small rate. Let's just make it a velocity of 10 kilometers per hour. Momentum is inertia in motion. So the the momentum of this bus moving with an inertia of, let's say 13,500 kilograms times, I'll put it down here, this 10 kilometers per hour, I end up with 135,000 kilogram times my kilometers per hour. Kilogram-kilometers per hour. Now, in order for the momentum to be greater, you did correctly say that the velocity has to be very fast. Let's look at how very fast. Let's say that we want to have the golf cart have the same momentum. Now the question is, where could it have more? Let's just see how fast a golf cart has to travel to have more momentum, or the same momentum as the bus. So the mass of the cart, 450 kilograms, the momentum of this cart, let's make it equal to the momentum of the bus moving at a very slow 10 kilometers per hour. This meaning, if I have these two factors, how fast would that cart have to go to have the same momentum of the bus moving at 10 kilometers per hour? We know that momentum is inertia in motion, but I want to isolate for velocity. Velocity is currently being multiplied by mass, so I'll divide both sides by mass. Therefore, given momentum and mass, to find velocity, you would take the object's momentum and you would divide by the mass. So the momentum of 135,000 kilograms times kilometers per hour divided by 450 kilograms, and I ran that through a calculator. I think that's about 300 in my units. That divides through, so I'm left with the kilometers per hour. So the golf cart, to have the same momentum as a bus moving at a relatively slow velocity of 10 kilometers per hour, it will be cruising at 300 kilometers per hour. Now, I very rarely point out the comparisons in non-metric, just to reinforce the concept with you of we use metric, but I think we should appreciate just how fast 300 kilometers per hour is. So in a non-metric, something you're much more familiar with in terms of driving, this 300 kilometers per hour is about 186 miles per hour. So in order to have the cart have the same momentum of a very slow-moving bus, this cart is traveling at over 180 miles per hour. One of the things we emphasize with you is the guide steps in solving problems, particularly focusing on the E. Evaluate, does your answer seem reasonable? A value of 186 filthy M words per hour for a golf cart is staggering. And this led me to some curiosity today to explore what is the fastest a golf cart has been clocked at. So I appreciate the opportunity to look up that the Guinness Book of World Record for the fastest golf cart is on the order of 118 miles per hour. And at the end of this, I'll include a clip of the world's fastest golf cart that I just looked at for you. Let's look at the take-home message here. You did reply to the question, when can a golf cart have greater momentum than the tour bus, in recognizing that your velocity needs to be greater. However, the amount of velocity to have more momentum of something within an incredible amount of mass, it's just mind-staggering. And so what I was kind of hoping this question would lead you to think about was the definition of momentum itself, with momentum being inertia in motion. And I wanted you to think about the very powerful, in my opinion, data value of 0. If the bus is not moving at all, its momentum is 0. Make space here. Could do a new page. I want to keep this information here for you. So if the bus has an enormous amount of mass, so momentum being inertia in motion, if this number is incredibly high, it could even be infinitely high mass beyond the scope of this course. But if you had a staggering amount of mass, but a velocity of 0 meters per second, kilometers per hour, then the overall momentum is always going to be 0 kilogram meters per second. And that is one way that I was wanting to try and drive, pun intended, your thoughts with this problem with the bus and the golf cart. That if your inertia is not in motion, you don't have momentum, because momentum is inertia in motion. So always keep in mind the power of this data point of 0. And now, enjoy the world's fastest golf cart.